Welcome to Homeschool Connections Physical Science class. Today we're going to finish Chapter 4, Elements, Compounds, and Mixtures by discussing mixtures. A mixture is a combination of two or more different substances. They can either be elements or they can be molecules, compounds, that are not chemically combined. No chemical change takes place within a mixture. Each of the substances, elements, or compounds retains its own identity. Think of a mixed fruit salad. You can see in the picture there. We have some kiwi, we have strawberries, probably some melons, some grapes. Each one of those fruits, even though they're all mixed together, keeps its own identity. That's a good picture of a mixture. In mixtures, we can separate out those elements or those compounds by some physical method, just like we could separate out that fruit mixture by picking each of those out and dividing them into their own separate fruit piles. I said we can always separate mixtures by some sort of a physical method. A few examples of this would be with a magnet. If we're trying to separate something that is magnetic from something that isn't, say iron shavings and salt. We could do it by evaporation. If the liquid evaporates and leaves the solid behind. If we've ever boiled the water away when we're cooking, we notice that film on the bottom of the pot. We have separated the water from the salt. We could do it by filtration. That's separating based on particle size. Think of your automatic coffee maker and the filter paper. The water runs through there, and through it comes the coffee, but left behind are the grounds, which are much larger. We could separate based on distillation. That's separating based on boiling points. If we have two liquids combined and one boils at a lower temperature and one boils at a higher temperature, if we keep it near the temperature of the one that boils at the lower point, that one will boil away and the other one will be left. We could do centrifugation that's based on density, that's making it spin really, really fast. And when it's spinning, the heavy things drop. And hence we separate the more dense from the less dense. A fun little fact, when they're harvesting cranberries, they use that physical property, density, in the harvesting. They flood their fields with water. The cranberries that are not ripe sink to the bottom. The cranberries that are ripe are less dense than water and they float, and they can just skim the top of the water and get all of the ripe cranberries and leave the ones that aren't so ripe in the fields. Let's compare mixtures and compounds. Let's first talk about their composition. Mixtures are elements or compounds, and they are mixed together. There is no chemical reaction taking place. Compounds, on the other hand, are made of elements that have chemically reacted to form a new compound. Mixtures can be separated by some sort of a physical means. To separate compounds into their elements, we need some sort of a chemical reaction. In mixtures, there are no chemical changes. In compounds, there are. With mixtures, you can mix them together in any ratio you so desire. Compounds, on the other hand, are very specific ratios. When describing mixtures, we can use three different terms: a solution, a colloid, and a suspension. And we're going to talk about the difference in those three. First, we have solutions. A solution is two or more substances that are evenly dispersed. Solutions often look like they are a single substance. For an example, milk. Solutions are made up, like I said, of two or more different substances. The solute is the substance that is dissolved in the solvent. The solvent is a substance that does the dispersing. For example, if you had a glass of water and you mix some salt into it, the solvent would be the water, the salt would be the solute. The solute dissolves in the solvent. Usually, we can easily figure out what is the solute and what is the solvent because the solute is usually the smaller quantity and the solvent is usually the greater quantity. We usually think of a solution as a liquid. Well, solutions can be liquids, but they can also be gases. They can also be solids. If we have a gas in a gas, both the solvent and the solute are gas, we can still have a mixture. An example would be the air that we breathe, oxygen in nitrogen. We could have the solute being a liquid and the solvent being a gas. An example would be humid air. We have water particles, a liquid, in air. Sometimes we can even have a solid in a gas. An example would be smog, where we have particles of soot in our air. We could have a gas as our solute in the liquid. That would be like our soda pop. Those CO2 bubbles would be a solution of a gas and a liquid. Sometimes it is liquid and liquid. For example, antifreeze that we put in the car, that's alcohol in water. Alcohol is the solute, water is the solvent. Sometimes we can drop a solid in water, such as seawater, salt water, sodium chloride in water. Now, the only one that's kind of rare is a solid solvent with a solute being a gas. We don't find those very often, but we can have liquid being the solute in a solid solvent. An example of that would be those old dental fillings. We don't use these anymore, but we used to mix mercury liquid into silver, a solid, and use that to fill teeth. A solution can also be a solid in a solid. An example of this would be bronze. That would be tin mixed into copper. Tin is a solute. The solvent is copper. Now, when we have a solid-solid mixture, a solution, we often call these alloys. Now, you don't have to memorize this. This was just given as an example so you can see that we have all different types of solutions. Oftentimes when we have a solution, we want to know how much solute has been dissolved into the solvent. And we do that by telling the concentration. We can have salt water that has only a little bit of salt dissolved in it, or we can have salt water that has a lot of salt dissolved into it. And we need to somehow express how much salt there is. First, we could use the words concentrated or dilute. Concentrated means that there's more. Dilute means that there's less. But these are only descriptive terms. We can quantitatively describe concentration if we measure the grams of solute per, say, milliliters of solvent. We can measure it numerically. The next type of mixture would be a suspension. A suspension is a mixture of particles that are somewhat evenly dispersed, but over time they will settle out. Think of your Italian dressing. Another interesting feature of a suspension is that it scatters light. Look at the picture at the bottom of this slide, a flashlight, and they're shining the flashlight through a solution and we cannot see the light, it just passes straight through. But if we pass it through a suspension, we can see the light because the light bounces off the particles and scatters it. We call that the Tyndall effect. Also, with suspensions, we can filter out particles. We can run that suspension through a filter paper and the solvent will filter out and the solute will stay on that filter paper. And like I said, an example of a suspension would be Italian dressing. It would also be the dust in the air. The dust tends to settle out onto our furniture, and then we have to go dust it. Another type of mixture is what we call a colloid. A colloid is a mixture with the particle size someplace between a solution, those very small particles, and a suspension that has relatively large particles. Now, the particles in a colloid will usually scatter light, but they cannot be filtered out and they do not settle out. Now, even if you have not heard the term colloid, we have colloids all around us. Colloids have a phase. They're a solid, a liquid, or a gas. The dispersant is that solvent-like thing, and that can be a solid, a liquid, or a gas. Notice whatever phase the dispersant is, that is also the phase of our colloid. Now, in that solvent-like dispersant, okay, we can have something that is dispersed, kind of like the solute. Now, if our dispersant and our dispersed are both gases, it is never a colloid. It is always, always a solution. But we can have a gas with liquid particles dispersed in it. We would call that an aerosol, and that might be something like a fog. If we have a gas with solids dispersed in it, we still call it an aerosol, but that would be more like smoke in the air. We could have our dispersant be a liquid, and in that have some gas. We call that a foam, and one of my favorite foams is whipped cream. Oh, yum. Okay, we could have a liquid dispersed in another liquid. We call that an emulsion. That would be milk. We could have our dispersant be a liquid. We could have solids dispersed in that liquid. We call that a sol. And a good example of that would be ink. Okay, ink is a liquid with solid particles in it. Now, if our dispersant was a solid and it had some gas dispersed within that solid, we call that a solid foam, and that would be like a marshmallow. The marshmallows are solid, but there are gases trapped inside. We could have a solid with some liquids dispersed. We call that a gel. An example would be cheese. We could also have a dispersant being a solid and the dispersed being a solid. We call that a solid sol. And some examples would be gemstones. Some gemstones are quartz, and the color are other solids dispersed in them, giving it their color. There is no need to memorize the various types of colloids. They were just given as an example. What is important is this comparison of mixtures. Our solutions are colloids in our suspensions. First, let's talk about them in terms of particle size. A solution, the particles of solute are very small. In colloids, they're kind of a medium size. And in suspension, the particles are large, sometimes even large enough for us to see them. Solutions, the solutes cannot be filtered out. They also cannot be filtered out in colloids, but we can easily filter a suspension. Now the Tyndall effect, does light diffuse as it goes through it? Can we see that beam of light go through it? In a solution, we cannot. But both with colloids and suspensions, we can see that beam of light. A good example of a solution would be ocean water. An example of a colloid would be mayonnaise. And an example of a suspension would be orange juice. That brings us to the end of Chapter 4, Elements, Compounds, and Mixtures, and the end of our discussion on mixtures. Next time we will start Chapter 5. And until then, God bless.